Hello everyone, welcome in a new video. In this video, we will discuss about contiguous memory management scheme. We discuss about contiguous memory management scheme. In a previous video, we discussed that the contiguous memory management is divided into two parts: single contiguous memory management and multiple partition. Okay, so first of all, we discuss about single contiguous memory management. We discuss about single contiguous memory management. Now, this type of memory management is used in a computer in a old days. Means in a previous generation, the computer system is basically work on the single contiguous memory management. In this system, the main memory is divided into two parts. In this main memory divided into two parts, and these parts are equal. Okay, two equal parts, the main memory is divided, and in one part the operating system is there. For example, this is what a memory. This is what a main memory is gonna look. Divided into two parts. One part OS reside always. In one part OS always reside permanently. Okay, and other part the process come and basically work and then terminate. So this is called a single contiguous memory management scheme. So OS is set permanently in one partition. Uh, in general, in general, if we talk about where in a memory, so if memory is divided like this, then at the lower part of main memory operating system is there in general. Okay, so in general, operating system reside permanently in a lower part of memory. Okay. So this is what basically a single contiguous memory management scheme. Process come and get the memory, do their work, then terminate. This is what a single contiguous memory. And you want to write, you can write it that the operating system reside permanently in one partition, generally at a lower memory. Generally at lower memory. Okay. And the user process basically load in the other part. This is what a single contiguous main memory. Now we are moving towards the important type, which is multiple partition. Multiple partitioning. Now, multiple partitioning, by its name, it is clear that now the memory is divided into multiple partitions. Means this is what we have a memory, and in the memory, partition is there now. Memory is divided into blocks. The memory is divided into blocks. These blocks are not always a fixed size. For example, like say this block is like 100 MB. This box is maybe 20 MB. This box maybe 10 MB. So the size of this main memory is not same. Okay, this is what multiple partitioning. Now, in multiple partitioning, it's further divided into two parts, which is called a fixed partitioning and a dynamic partitioning. Okay, they're divided into two parts: fixed partitioning and multiple partitioning. Let's discuss about, first of all, we discuss about fixed partitioning. Fixed partition, contiguous memory management. Okay, so now what happened in the fixed? The main memory is divided into several fixed size, and fixed size, or you can say the fixed partition, in which fixed partition memory management. uh, for example, let's, with the help of example, let's understand. This is what a main memory. Main memory divided in a fixed partition. Fixed partition doesn't mean the memory available on this is fixed. Means if this is a 100 MB block, this will be a 100 MB block. There is no shifting of size take place. Okay. These partition can be of same size or maybe of different size. For example, 100 MB, 100 MB this block as well. 20 MB this block means same size partition will be there and different size partition will be there. Okay. Each partition can hold a single process. This is very important point. Okay. Each partition can hold a single process. Single process. Each partition can hold only a single process. Let's say P1 is a process, so P1 will reside completely in a first block. P1 reside completely in a first block. This is what the meaning of a fixed partition. Okay. Now, the number of partition determine the degree of multiprogramming. Means if there is a 10 partition, then 10 is a degree of multiprogramming. Means 10 process can reside in a main memory, and 10 process can execute at a particular 10 process can be executed. Okay, so the number of blocks number is equal to the degree of multi-programming. Next, these partition are made at the time of system generation and remain fixed after that. When system is generated, the partition is there. The partition is made at a generation of a particular system and it always same. Okay, so these are the fixed partition concept. I hope you understand this thing. Now, the important point, which is that in this case, the operating system is on the top. The top block is basically operating where the operating system resides. In a top block, operating system resides. Now, we understand about fixed partition. Now, there is a concept called internal fragmentation. What is internal fragmentation? Now, what is internal fragmentation? In internal fragmentation, when space is allocated to a particular process more than it's required, then the remaining space, the extra space is basically wasted, and that wasted space is called internal fragmentation. What does this mean? This means that we have a main memory. We have a main memory of 4 partition. Let's say 200 MB space was in this block. P1 is a process. P1 is a process which basically need 100 MB of space. P1 is a process which need only 100 MB of space. But due to contiguous memory allocation, P1 is allocated to this block. P1 is allocated to this particular block. Now, the extra 100 MB space, because P1 only need 100 MB. So 100 MB is utilized. But in this block, there is 200 MB space. So the 100 MB extra space is called internal fragmentation. The extra 100 MB space is called internal fragmentation. So if you understand what is an internal fragmentation, so when a space allocated to a process is more than it's required, then the extra space is wasted, and that waste of space is known as internal fragmentation. That waste of space is known as internal fragmentation. So I hope you understand about internal fragmentation. Now, after internal fragmentation, let's understand that how basically the process is basically allocated to a particular memory. For example, we have a main memory and we have main memory divided into some blocks. Now, how, let's say we have 6 process P1 to P6, how P1 to P6 is allocated to this block we see this thing. Okay. So how partition allocation policy work, we see this thing. Partition allocation policy. Okay. Now the first one is called first come first serve. Oh, sorry, first fit. This is called first fit. Now what does this mean? This means that if P1 come, let's say P1 to P6 come at 0, 1, 2, 3, 4, 5, 6. Oh, sorry, 5. Let's say that P1 to P6 process are come in a that sequence. Means first of all P1 come, then P2, then P3, then P4, then P5, and then P6. So those process who come first get the memory first. Doesn't matter what the requirement of the memory for the particular process. For example, let's say this is 200 MB, 100 MB, 50 MB, 500 MB, 250 MB. If P1 need only 50 MB space, doesn't matter. If P1 come first, P1 allocated to that particular first block. If then P2 come, then P2 allocated to the second block. Those who come first will get the memory first. So it means that the first partition from starting store the process which allocate basically. So those processes come first, get the memory first. Okay, so that's easy. There's no need to write about it. Now the second is called best fit. Best fit. Now what is a best fit means? Best fit means that if P1 is a process that need 50 MB of space, P2 is a process that need 500 MB of space. Let's talk about these two processes. So P1 doesn't, so P1 is not, P1 basically need 50 MB of space. So P1 goes to that block which is of 50 MB of size or less than 50 MB of size, so that there is a very small wastage of memory. Okay, P1 need 50. It check if there is a 50 space, 50 MB space there in any block of 50 MB size. If it find, then P1 will go there. Similar. If P2 need 500 MB of a space, it check 500 MB is there. So definitely one block. So P2 is allocated to that block. This is called best fit. Okay. Now the third one is called worst fit. By its name it is clear. Worst fit. By its name it is clear that it gonna do the worst. Means if like P1 need 50 MB, so it find that place. Okay, so it find that place where the maximum memory is there. So every block is empty. It find that the process find, the operating system find basically there is a block size of 500 MB and we have a process of 50 MB. So what it does in a worst fate, the P1 process assigned to that memory which having a very high memory. Okay. Uh, Now that process will go to that block which have a very high memory. Okay. So P1 goes to P2. Regardless, P1 can go to the first block, second block, third block, fifth block, any block, but it goes to that block which have a very high memory space. Okay, this is called a worst fit. Now the fourth one, or you can say last one, is called a next fit. Now what does this mean? This means that let's say we have a process P1 which need 50, P2 which need 250, P3 which need, okay, so P2 let's say we need 450 and P3 which need 200. So what next fit says? Next fit started from the first part. Let's say P1, because P1 is a process which comes first, so P1 is allocated to first. Now, in a next fit, what happened is P1 check that if there is first block, if there is a space, And yes, there is a space. So P1 reside there. P1 reside there like first fit. Like first fit. P1 reside there. Now in the second case, P2 need 450 of space. So it's check second block. It check second block that what's the space 100 MB. Definitely not able to reside this. And in third, it needs the space is 50 MB. Definitely uh, not able to access this space. Now the third one is 500 MB. So P2 allocated to this part. P2 allocated to this part. Then P3. Now, what the next bit says, where you leave the process, the next allocation of memories is started from the next next block of that particular process. Now, in a starting point, a cursor is here. P1 is in first block. P2 we check for the memory after the P1 block. P1 placed at first, then we check next block for the P2, next block for the P2, next block for the P2, P2 decide there. Now P3 let's say need 100 MB. You cannot place P3 over here. You cannot place. This is called first fit. This is called first fit. You cannot do this. What you have to do is you have to check the space next from the previous process which you allocate the memory. So the previous process is what P2. P2 allocated to this block. Now you have to check this block, the next block of that particular process. So P3 need 100, 250 space. P3 can easily reside there. So P3 can get. Now let's say P4 is a process which need 100 MB. So now you can start from the start. This is how the next bit works. Where you leave the process, next process memory allocation will be started from that next part. Okay, so this is how the partition allocation. This is how the basically the memory allocation will work. Okay, question, and we are good to go for the next part. Okay, so we have a processes. Let's say we have a processes P1, P2, P3, P4, and P5. We have a 5 processes of size. P1 is a process of size 150 MB. P2 is a process of size 400 MB. P3 of 270. P4 of 180, and P5 of 50. Now, what you have to do is you have to apply the fit, first fit, best fit, and the worst. Okay. Now, the space of main memory is look like 100 MB, 250 MB, 200 MB, 500 MB, 300 MB. Okay. So these are the these are the 5 spaces, and these are the memory. Now, what you have to do is you have to add this. What you have to do is you have to add this process. That's it. Okay. These are the block size. These are the block size. Now, first of all, you have to apply the first P. P1 is a process who come first. So what is basically the memory? So I write like this so that there is no. Okay. So now we're gonna apply first bit. We have to apply the first bit. Okay. So 150 start from the starting. 100 MB definitely P1 process not able to access this part because this is less than what it needed. Second, 250 definitely P1 able to access. So if it is able to access in first bit, then it will. Okay. So 250 memory. This part is goes to P1. Okay. Now second is 400. This is the first bit we have to start from the starting. Now, first block 100 MB definitely not able to access. 250 not able to access. 200 not able to access. 500 yes. For P2 process will get 500 of memory space. 500 MB of memory space. P3 process start from the starting. Now this part is okay. So uh, now this part is allocated this. this part is allocated. Two part is allocated. Now the third one is P3. Start from the starting 100 MB, 250 is needed, definitely not able to access. P4, 180, oh sorry, P3 now moving towards the next block which is 200, definitely not able to access. Then the block left which is 300. So and P3 able to access this block because block size it needed memory of 270. Here the memory is 300. Definitely this block is accessed to the P3. Now the last block is also allocated. Two block left, 101 and the 200. Two process left. P4, 180 needed. Start from the starting. Start from the starting. 100 MB definitely not able to access this part. 200 MB definitely P4 will get this block of main memory. Okay, so 200 will get to P4. P5, one part left which is 100 and the process size is 80. P5 get this block. So 100 MB goes to that. What is internal fragmentation? Means the wastage of extra space. 100 is the main memory size. Process need 80 means 20 MB is a wastage. 20 MB is a internal fragmentation. Okay. Now this is called first fit. Now we are moving towards the best fit. What best fit says? Okay. So now we remove this. Now we start from the start. Okay. Now best fit process where less internal fragmentation there. Or we are going to add that process to that particular memory where less internal fragmentation occurs. P1 process 150. Let's see that 100 on definitely not able to not able to access this because the process size is 150, the block size is 100. Second is 150. We can we can basically P1 can allocate this 250 MB of space, but we are not gonna do this because there is an internal fragmentation of 100 MB. 150 process needed, 250 is a size. So if you subtract this, you will get 100 MB of wastage space, or you can say the internal fragmentation. So we cannot do that. This is the best fit. Less internal fragmentation. We have to choose that block which is having a less internal fragmentation. Second, let's say we go to the we go the fourth one, which is 500 MB. So definitely you cannot do this as well because there is a 350 MB of internal fragmentation. You cannot do that as well. 300 definitely you cannot do this because it's the best fit and you cannot do that. There's a 150 MB of internal fragmentation. Better to use 250 rather than 300. Now we have one block which having a 200 MB of space. So 200 minus 150, you will get 50 MB of internal fragmentation. You get 50 MB of internal fragmentation. So which block having a less internal fragmentation, we provide that space to that particular process. So 200 MB goes to P1. 200 MB goes to P1. So I hope you understand this thing that how we allocate this space. Okay. So let's remove this for the next process. Now P2, which is a 400. Now this part is allocated. P2 400. So in 101, definitely not able to reside, not able to reside in 250 as well. 200 already filled. 500. Yes, we can provide this. We can allocate this memory to P2 because there is only one block which can able to provide memory to that particular process because there is a 300 less than 400 memory is less than the process size. So definitely only one block left which is 500. So 500 is also allocated to P2. P3 270. So 270. Now similar case 101 we cannot provide this space to P3 because the size is less than the process size. So we cannot do that. 250 and 300. We choose that block which gave a less internal fragmentation. So 301 gave more internal fragmentation. Here the internal. Okay. So this is 270 and there is 50 only one block left which is 300. So definitely P3 will goes to 300. Because 250, the process size is 270 Only one block left, the last one. So that block is there. P4 180. Now two part of block left, 101 and 250. Cannot reside on the first block. So definitely second block allocated to second 250 memory space is allocated to P4. So 250. Now for P5, 81 block left. So and able to access that, able to allocate this block. So 100 MB allocated to P5 block. Now we're gonna do the worst fit. We have to do the worst fit. Worst fit says that highest internal fragment. Worst fit says we need high internal fragment. So let's say P1 process 150. Worst fit choose that block which having a very high space. So among all these five blocks, 500 MB is the largest space. So P1 get 500 MB in a worst space. So what's the memory internal fragmentation here? If I have to calculate the internal fragmentation, so what's internal fragmentation is 500 minus 150, which is 300 MB of internal fragment. Highest internal fragmentation in a worst fit, in a best fit, less internal fragmentation. P2, 400 definitely cannot access any of this block because there is only one block which can able to get P2, which is the block number 4, but that is already allocated to P1, so definitely P2 doesn't have anything. Okay, remove this. So P2 does not have anything and 500 is allocated. Now P3 270, highest one is 300, so 300 can able to get this, so 300 MB will get to P3. 300 is also allocated. Now the space left is 100, 250 and 200. P4 180. We choose that process because it can reside on the second block and the third block, but we choose that block which give a highest internal fragmentation. So 250 give a highest internal fragmentation, so 250 allocated to P4. Right? Now 80, we choose that process which give highest internal fragmentation. We can assign P5 on first block, 100 MB block, but we cannot do that because it gives less internal fragmentation. We need worst. So 200 MB of space is allocated to P5. So this is how we can solve this question. So I hope you understand that how we solve this question, how the best fit work, worst fit work, and how the first fit work. Okay, now you can write like that. If you want less internal fragmentation, then you have to use the best fit. So it means that best fit works better in fixed partitioning or fixed partition. Okay, best fit work in a fixed partition, contiguous memory. Okay, so I hope you understand this thing. Now we discuss about we discuss about the internal fragmentation and the fixed partition. Now the next concept is called a dynamic partition. We see dynamic partitioning in the next video.